Hello everyone, welcome to the course on Foundation and Substructure Construction. I am Xu Yi, the lecturer of this section. Through the last lesson, we've learned to use the grid method to calculate the earthwork volume for site leveling. Today, we will continue to learn another method for calculating the earthwork volume for site leveling, cross-section method. Meanwhile, master the allocation principles and steps of earthwork for site leveling so as to lay a good foundation for future engineering practice. Let's start together. The tasks in this section include 3 parts. First, master the cross-section method and the methods and steps of calculating earthwork volume. Second, grasp the principles of earthwork allocation. Third, master the steps of earthwork allocation. Next, let's look at the applicable conditions of the cross-sectional method. The cross-section method is suitable for areas with large terrain fluctuations or areas with long and narrow terrain, large and irregular excavation depths. The calculation method is simple and convenient, but has low accuracy. Next, let's look at the calculation steps and the methods of the cross-section method. First, cross-section division. The site to be calculated is divided into several cross-sections according to the site surveying and mapping, vertically arranged of the topographic map, such as A-A, B-B, C-C, etc., as shown in the figure. Make the section as perpendicular to the contour line or the long side of the main building as possible. The spacing between the sections can vary, generally 10 meters to 20 meters. In flat areas, it can be larger, but the maximum is not greater than 100 meters. Second, draw cross-sectional graphics. Draw the natural ground and design ground outline of each cross-section in proportion. The area between the natural ground outline and the design ground outline is the cross-sectional area of cut or fill. Third, calculate the cross-sectional area. For the cross-sections whose shapes are shown in the table below, the cut or fill cross-sectional area of each section can be calculated according to the relevant cross-sectional area formula, as shown in the diagram in the table. Fourth, calculate the earthwork volume. According to the calculated cross-sectional area, perform calculation according to the following formula. V equals to R1 plus A 2/2 times S. Where V represents the earthwork volume between two adjacent cross-sections, A1 and A2 respectively indicate the cross-sectional areas of cut or fill of two adjacent cross-sections. Shortening the and S indicates the distance between the two cross-sectional areas. Next, let's look at the principles and steps of earthwork allocation. The principle of earthwork allocation is an important content in the organization design of earthwork construction. After the calculation of earthwork volume of leveling site is completed, we should prepare for the earthwork allocation. The plan divides the cut area and the fill area into several allocation areas. According to the terrain and geographical conditions, calculate the earthwork volume of each allocation area. Calculate the average transportation distance between fill areas and cut areas of each team, and determine the earthwork allocation scheme between cut allocation areas so as to minimize the total transportation volume or the total transportation cost, facilitating the construction, shortening the construction period, and lowering the cost. The principles of earthwork allocation should be as follows. 1. We should strive to achieve the principle of balance between cut and fill, and the shortest transportation distance. 2. Earthwork allocation should consider the principle of combining recent construction with future utilization. 3. The earthwork allocation should be considered by the principle of combining zoning with the whole site. 4. Earthwork allocation should also be combined with the construction of large underground buildings as much as possible to avoid repeated cut, fill, and transportation of earthwork. 5. Arrange the cut and fill curves collectively, and select the appropriate allocation direction and transportation route so that the performance of earth-moving machinery and transportation vehicles can be fully exerted. Next, let's look at the steps of earthwork allocation. 1. Divide the allocation area. Draw the dividing line of cut and fill on the plan, and draw several allocation areas in the cut area and fill area to determine the size and the position of the allocation areas. 2. Calculate the earthwork volume in the allocation area and mark it on the map. Calculate the average transportation distance of each team's allocation area, that is, the distance from the center of gravity of earthwork in the cut area to the center of gravity of the fill area, and mark this distance in the earthwork balance and transportation distance table. 4. Determine the optimal allocation plan. First, use the minimum element method to determine the initial plan, and then use the potential method to check whether the total transportation volume is the minimum. Otherwise, use the closed-loop method to make adjustment and draw the earthwork allocation diagram. Then mark the allocation direction, earthwork volume, and transportation distance according to the above results. I hope everyone can gain something through this lesson. That's all for this lesson. Thank you.